Single displacement reactions are examples of what are called redox reactions where we involve an electron transfer. There's a whole section dedicated to redox reactions that we're going to study later, but we can manage at this time some of the basic redox reactions, which are single displacement reactions. So as you know, the general format for this kind of reaction is A plus BC going to AC plus B. So we can either have a metal displacing another metal, or we can have a non-metal displacing another non-metal here. This is the activity series of metals, and it basically puts in order the metals from the most reactive to the least reactive. So these metals at the top are more likely to lose electrons than the ones at the bottom. And what you'll see is that there's different sections here. So anything in this from sodium to lithium, these will react with water quite vigorously. This section here will react with steam, but you're not going to see that covered very commonly. Okay. Anything above the hydrogen here, these ones will react with acids to produce hydrogen. Okay. And then other than that, this list can be used to compare the reactivities of one metal to another. So for example, if I look at something like a piece of zinc reacting with a solution of copper sulfate, I can use the activity series to decide if this reaction is going to occur. Zinc is higher up on the activity series than copper. So that means that zinc is going to be able to displace copper. If it was the other way around, no reaction would occur. So I'm going to end up here with zinc sulfate and copper. Okay, so for example, if I did magnesium plus sodium chloride, okay, magnesium is lower than sodium, so no reaction would occur. One of the great things about the reaction section in the AP exam is that all the reactions that you're given will occur. So although it's important to recognize the activity series at this stage, the reality is the reactions are never going to end up being no reaction. So if you understand and are able to predict that when you've got a metal reacting with an ionic compound, you're going to have single displacement, that'll be good enough. The activity series for halogens. Okay. Halogens, much like metals, can displace one another. Fluorine is most likely to displace, okay, versus iodine, and these just fall in order the way that they're on the periodic table. So for example, if I've got fluorine reacting with sodium chloride, because fluorine is higher up on the activity series, it's going to be able to displace the chlorine here. So I will get sodium fluoride and chlorine gas. Okay, and I recognize that that's unbalanced, but we'll worry about that later. Okay, so the different kinds of single displacement reactions, you can have a metal replacing a metal. Okay, so in this case, the aluminum is going to displace the nickel. You can have a non-metal displacing a non-metal. So in this case, the chlorine is displacing the bromine. Now we can also displace hydrogen. Okay? Metals can displace hydrogen. As you saw with the activity series, some metals will react with water and some metals will react with acids. When they react with acids or water, what they're actually displacing is hydrogen. Okay, so actually just picked up on an error here. So this should actually be H2. And that should be 2 HCl. Okay, so when you've got magnesium reacting with hydrogen, if you look at the activity series, it does in fact react. Okay, and what's going to happen is the magnesium is going to displace the hydrogen. So the magnesium will combine with the chlorine in its normal formula, MgCl2, and what's being displaced here is H. And H gets displaced not as H+, but as hydrogen gas. Okay, this is a classic reaction you do in grade 9 and 10 science for the hydrogen test. Okay, it produces a good amount of hydrogen that you can test for. Okay. When you've got a metal with water and it reacts, so something like sodium plus water, and you've seen this in the past, I know. Again, you're going to displace hydrogen. What you want to do is think of water in this reaction as HOH. That'll help you to see what the products are. The sodium is going to displace the hydrogen as H2, and then the sodium is going to combine with the hydroxide. Okay, so your products here are sodium hydroxide and hydrogen gas. Okay, so these are the different examples. So these are just a few little tips here for when you're studying single displacement reactions. Strong